Hello everybody. Welcome to today's tutorial. Am I coming in loud and clear? Let me know in the chat. Hello, Steve. Thank you. So we have 13 people here. Thanks, Oliver. And I'm just going to say that today's tutorial is about lab test 2, which is next week. So as I've said in the poll, if you don't want Mobius Maple revision, then maybe go to a different tutorial for today. Okay. So anyway, I hope you're doing well. And I asked the class in today's lecture, would you like some revision lectures? And most people said yes. So I'm recording this session and I'm just going to go through the practice exams. Okay. So let me know what's going on. Let me know if you have any questions. Everybody can use their microphone or their camera or whatever. But let me get down to it. So here is the lab test. Okay, so this is the calculus. I thought I would concentrate on the calculus today. There's like 16 questions, but a lot of them are repeated, right? They're the same kind of idea. Okay. So let's work through this, and then we can, move through, and you can ask me some questions if you want to, and we can solve these things together. All right. So find to 10 significant figures the unique turning point of this function in this interval. Okay. So this is one of the questions where you'll need Maple. Okay, you can't really do this by hand, but you can do some of the Mobius questions by hand. Okay, so this is definitely a Maple question. Okay, so let me share my Maple screen with you, and we can have a look. All right, so you can see up here, I've defined the function f of x. Now, obviously, these things can cancel, but because everybody's function is different, they just choose like, different variations. Okay, so I define my function f, and that confirms that it's the function I want. And to find the turning point, what I'm going to do is differentiate the function and then set it equal to 0. Okay, so if I differentiate the function with a new with a diff command, I'll get something like this. And what I want to know is, well, where is that 0 in this interval? Okay, so I can use the fsolve command there. I've defined it as a new point C, but I mean, you don't have to, but I just have, right? And so we get this point. So this is the sort of the x point where our turning point occurs. And so if we go back to our question now, I've basically just copied and pasted my C point in there. Okay, so how did I do? Yay, okay. Now, in the real exam, you won't get how did I do, unfortunately. All right, so that's the first part of this question. The second part is find to 10 significant figures the value of the second derivative at the turning point. Okay, so I want to take this and substitute it into the second derivative of f. Okay, so let's see if we can do that in Maple. So you can see here I've defined a new function h, which is the derivative of g. So that's like the second derivative of f, right? So I've differentiated it. I get this function here. And what I want to do then is evaluate the function at my point C. Okay, so I do that. It's not in a very nice format, so what I'll do is I'll evaluate it as a decimal. Okay, so that's going to be the value of the second derivative at the turning point. Okay, so if I go back to my exam now, you can see down here that's where I've just copied and pasted the value from Maple into there. How did I do? Yay, it's correct. Okay, so are there any questions for that one? Let me know in the chat. There's a question now. So what is the difference between solve and fsolve? Fsolve, I think, gives you the function as, hang on, let me just look this up. Good question. Usually the F, it means you want the answer as a decimal in floating point arithmetic. Does that make sense? And with the other one, it might give you an exact value, Oliver. I think that's the difference. Don't quote me on that, but I think that's the difference. So for fsolve, you'll get a decimal. I think that's it. But let me just look that up. Yes, that's it. Yep. So I was correct. So with fsolve, you'll get a decimal, right? So I think that's correct. All right. So let's go to the next one. Okay. So this is a question that a few people have asked me about today. And so I thought I'd do it. It's very similar to the previous example, right? So let me scroll down here on my Maple and we can have a look at it. Okay. All right. So you've got, again, a function. Find the turning point, so when the derivative is 0, in this interval. Okay, so let's do that first and then find the value of the second derivative at the turning point. Okay, so let's go back to my Maple window and we can do it again. So here it is. So I'm just basically repeating the steps that I did before. So I'm defining a function p here, and I'm differentiating it, and then I'm solving it. I'm finding where the derivative is 0 for the x values between 1 and 2, because that's the interval that the question tells us to focus on, right? So I do that, I get this value, and then I input that into my Maple window. So let me just go there and I'll show you. So there it is. Okay, so how did I do? Whew, great. All right, so the same procedure now, second derivative of f double dash at the turning point. Okay, so let's go back to our Maple window. And you can see here, I've just differentiated the derivative, right, with respect to x. I got this, and then I've evaluated it at the point, at the turning point. Okay, so I get this. I can put that into my little box. Oops, I just put that into my little box. How did I do? Yes. So hopefully with those ones, you can see that the idea is very similar, okay? And there's a whole bunch of repetitive questions involving the same kind of steps. So these are two problems that I think are pretty easy to solve once you know what to do. And you just need to be a little bit careful with the syntax and all that sort of stuff. So are there any questions so far? Let me know on the chat, or feel free to turn your microphones on if you guys want to ask a question on how it's going so far. But let's check out the next question. All right, so this one looks like an integration question. Okay, and this integral here is way too hard to do it by hand. Okay, it's way too hard to do it by hand. So, Maple to the rescue. So let me just pull this up. Yep. Okay, so I think the reason they're asking you these questions is so you get the syntax right for the integral. Okay, even though there's no pi in there, but the exponential's there, infinity is there, and a few other things. Okay, so those first three things are pretty easy, and you can always check, of course, that you're actually inputting the correct thing. Okay, and so the way I did this was put this into Maple, and let me share that with you now. So you can see here, I've just done everything in one step, basically. I mean, you could, if you wanted to, just define the integral and then evaluate it, okay? But I haven't done that. I've just put that in like that. Maple takes a little while to do that, and then I just copied and pasted that into the window. Okay, so you've got the exponential times the sine of this divided by that, and you're integrating with respect to x from x equals 0 towards x equals infinity. So that's kind of the syntax. Okay. So if I go back now to my box down here, okay, well, how did I do? Oh, got it. Okay. So not too bad there, not too bad. And this is a really difficult integral. I don't think you could do this by hand at all, right? I don't think it'd be very easy to find an antiderivative of that. Okay, let's keep going. We're on a roll. Okay, here's another one very similar to the previous question. What is the Maple expression for inverse tan? Well, it's arctan, right? What is the Maple expression for pi? Well, we saw that. The Maple expression for the imaginary unit is I. Okay, let's have a look at that one. I, not L, I. Evaluate to 10 significant figures this integral here. So you already know what this is going to be in Maple. You just need to type it in. So let's have a look at the Maple window. Okay, you can see here, what I've done first is I've actually defined, well, I haven't, I've just written it down, right? Okay, and then that's just one step to ensure that you get exactly what the question is asking you to evaluate, and then I've just evaluated it. Okay, remember the percentage sign means evaluate the thing that you just looked at. Okay, so I've copied and pasted that into my box, and and I'll get something like this. How did I do? Yay! Okay, so you're probably seeing a pattern now with these kinds of questions. They ask you for some syntax, and then that syntax is partially related to the integral. Okay, I think this is the last one. Maple expression for cosec is this. Remember, you can check it, cosec. The Maple expression for the constant pi is pi. The Maple expression for e to the x is exp x. And then there's an integral. Okay. So let's have a look at what we're doing with the Maple window. And you can see here, I've just done everything in one step. Okay. So rather than what I did in the previous thing where I tried to do two things, well, I did two things, I just did everything in one step. Okay. And so you're going to take that, copy and paste it into Maple. Okay, so let's go back to Maple and to the Mobius, sorry, and let's see what's happening there. Okay, so I've copied and pasted down there. How did I do? Oh, gosh, not making any mistakes today. All right, so here's another one. Similar idea, inverse cot of x, arc cot. Okay, pi, infinity, and then an integral. Okay, so if I go back to my Maple window, you can see that I've done that in one step. Okay, so here you're integrating from negative infinity to infinity. So you just need to be careful with the limits of integration. Okay, and so I get that answer, copy and paste that, and put it into Maple. Okay, so how did I do? Woohoo! All right. All right, finally a different question. Yes. Okay, so what's this question about? Well, it is about polar curves or polar plots. Okay, select the option below which is the plot of the following polar curve. That's it for theta between 0 and 2 pi. Okay, so you've got some options here and you just want to choose the right one. Okay, so what I would do with this one is just plot this function in Maple using the polar plot command. Okay, so how do you do that? Well, I'm glad you asked. Let's have a look. So you can see here I've used the plots calling sequence. Okay, and the most important thing for our question is this polar plot. Okay, so you run the calling sequence and then you can see what I've done in the next line. I've said, right, give me a polar plot of this function for theta between 0 and 2 times pi, and Maple gives me this. Okay, and so what I'm going to do now is just compare that graph against all the possibilities that I could answer with. Okay, so let's have a look. So it's not that one. not that one, not that one. Oh, that one, not that one, not that one. Okay, so how did I do? Yay, I got it right. Okay, there's a whole bunch of these ones. I probably won't do all of them because they're a bit boring after a while. But the process is the same, right? So let's keep going until we find something else. Oh, okay, so this is a good one. Okay. So find the largest interval of this form containing the point 3.7, so x equals 3.7, on which the function f defined by this, okay, it's like a cubic equation, has an inverse. Okay, so what do we know about inverse functions? Well, one strategy here is to show or just to find out where f is 1-to-1. Okay, and I mean all I've done for this is look at where the derivative of f is either positive or negative. Okay, so the way I've done this question is to say here's a function and an interval or a point. Where is the derivative positive or negative? Okay, in an interval containing that particular point, 3.7. Okay, so what does it look like in Maple? Well, I am glad you asked. All right, so here I've defined the function that's given to me. Okay, and what I've started with is a plot of the graph of the function. Okay, so I've just used the plot command for that. And what I'm actually interested in is the derivative of this function. Okay, so I've differentiated the function with respect to x, and I get this. And then what I'm going to do is find the points here and maybe here where there are stationary points, where the derivative is 0. Okay, because I know that between those 2 points, the function is going to be either increasing or decreasing, right? So you can see here, the function has a stationary point around here and another one around here, just from the graph, okay? And so between those 2 stationary points, the function is going to be decreasing. I can see that from the graph. And in particular, that interval contains the point 3.7. Okay, so when I've found the derivative, I get the point 2 and 6. So x equals 2 and x equals 6. Between those 2 points, the function is decreasing, right? Strictly decreasing. And therefore, it must have an inverse because it's 1-to-1. Okay, so let me know if you need me to explain that a bit more, because there's a lot going on in there, right? So I've defined the function, I've plotted it, I've differentiated it, and I've found the stationary points. Okay, between those 2 stationary points, the function is decreasing. That's the interval that we want because it contains the point 3.7. Okay, so let's go back to the question. So you can see we want an interval like this containing the point x equals 3.7. And this interval definitely will contain that point. Okay, how did I do? Phew. Oh, lucky, so lucky. All right. So that's an important question, because some people, they're not even sure where to start that question, right? But you're just looking for, in my solution, you're looking for the stationary points and the right kind of interval. All right, here's another one. Consider the function defined by this rule. Okay, so it's a absolute value kind of function. Find all the critical points of f in this interval. Okay, so remember, critical points occur at the endpoints, at a point where the derivative's 0, or at a point where the function is not differentiable. Okay, so let me see if I can find what I've got there in terms of graphs. All right, so let's go over to my Maple window. Okay, so that was the question I was doing before. Let me just scroll down. Okay. All right. So what I've got here is I'm just going to use the plot command to plot the absolute value of this. So ABS stands for absolute value. And I want to plot it between x equals -2 and x equals +2. Okay? So there's a plot. So you can see that, okay, well, of course, at the endpoints, they're critical points. So x equals -2 and x equals +2 will be in our list. And what I've done on the next line is to, I've gone back and defined the function, and then I've differentiated it, okay? What I'm trying to find is this stationary point here, okay? So I've differentiated, I've set it to 0, and I come up with -1/3. So around about here, x equals -1/3, that's a stationary point. So I've got -2, +2, -1/3. And who can tell me what's another critical point? What's another critical point on the chat? Who can tell me? Yes, Kevin, x equals 1, right? So that point there. Yeah, absolutely. So there's 4 points of interest: -2, +2, 1, and -1/3. Okay. So if I go back to my my Chrome tab, Steve, are you? I'm just looking at your comment in the chat. Are you doing Math 1081 as well? Yep. Last question. Yep. Okay. So so let's enter them in the box. There they are. Are we correct? Yes. Okay. So now there's a whole bunch of drop-down boxes. So the function f is guaranteed to have a maximum and a minimum value because it's a continuous function on a closed interval. Okay. The maximum value of f on this interval is, well, it's going to be 25. You can see that from the graph. The minimum value is going to be 0. So let's go back to the Maple tab. You can see here's the maximum value, right? Just happens to be at x equals 2, the value is 25. Here's the minimum value, 0. Okay, so that's pretty easy. So heading back to our questions, so 25, 0. At what type of critical point or points does the maximum occur? Well, it occurs at the endpoint when x equals 2. At what type of critical point or points does the minimum occur? Well, the minimum occurs at like a spiky bit, right? So a point where f is not differentiable. Okay, did I get it all right? Yep. Okay. All right, so the following question looks like it's about the L'Hopital's rule. Okay, so for f and g real functions defined on a suitable domain, and a is a real number in the domain, L'Hopital's rule says that this limit equals this limit provided the following conditions hold. Okay, so there's a bunch to choose from there. So the first one is definitely A, because you want the indeterminate form, right? So infinity over infinity, you know, those sorts of things, 0 over 0. So that seems fine. B is not correct because it's got nothing to do with the derivative. It's got to do with the function. Okay, this is not correct. The limit of this thing definitely has to exist, and this part E plays no role. Okay, so I think it's A and D. All right, so the question is, can the following limit be calculated using L'Hopital's rule? Okay, well, as x goes to 0, that goes to 1, right? Cos of 0, the cos of x goes to 1. So that's a problem because that doesn't go to 0 or infinity. Okay, so which one's violated? Part A. Okay, so let's check it. Phew. Oh, so lucky today. Okay. So here's another one, almost the same. So you can see it's the same question starting again. So we'll just choose the same answers as before. And then, can the following limits be calculated using L'Hopital's rule? Okay. So if you can, enter the value of the limit. If not, enter a letter corresponding to the property above that is violated. Okay. So what's happening here? Well, this limit goes off to positive infinity. The bottom limit goes off to positive infinity. So that looks good so far. But the problem is if you differentiate this and you differentiate that, then the limit doesn't exist. Okay, so it's D that's the problem. Can anyone tell me on the chat, how would you solve this limit? Who can tell me on the chat? There's 14 people here, right? Who can tell me what would be your strategy? Kevin says squeeze theorem. Is he right? Anyone else want to confirm or deny what Kevin is saying? Come on, don't be shy. Yep, divide top and bottom by x, Oliver. Yep. And maybe then use the squeeze theorem. Yeah, that sounds like a pretty good strategy to me. Yeah, so Kevin, you're correct. And Oliver, you're correct. So bring them together. That's a perfect solution. Okay, so how did I go? Ah, it's so good when you see the green, isn't it? All right, something different. Something different. Plot the two curves defined by this equation and this equation. Find the number of intersections of these curves in the following square region. Enter the number of intersections. Okay, so you can see these are relations. So they're sort of implicitly defined. We want an implicitly defined plot here. Okay, so let's have a look at Maple, and we can see what's going on, hopefully. All right, so I've already used the calling sequence to get the plots. Okay, so let me just go down here if I can. Okay, so you can see the implicit plot. I've used this expression here and this expression here. The square brackets, you've kind of got a list of things there, and you want to plot both of them on the same pair of axes. So that's what you can do. It's like a little list of functions, and you want to plot both of them. It tells Maple, oh, I want to plot both of them. And here's the region from x equals -10 to 10 and y equals -10 to 10. And the color, you don't have to do this, but I've just put the first one to be blue and the second one to be red. It just helps you tell them apart and see where they cross. Okay. So from that picture, you can definitely see, well, it looks like there's one and only one point of intersection. Okay. So if I go back to my question, I can see, well, how did I do? Yay! I got it. Woohoo! Life is good with the green. Okay. So there we go. So what do you think, folks? That is all the calculus questions done. Well, I haven't done all the repeated polar plots, but they're very easy. They're one of the easiest ones to do. So what do you think? We got a couple of minutes. What would you like to discuss? In the 4 o'clock tutorial, I think I'll do the algebra solutions. So I think I'll just leave them until the 4 o'clock algebra. Oh, Steve, why do you hate Maple, buddy? Is it just because it's new or what? Feel free to turn on your microphone if you want to. I can stop recording now. Let me stop recording.